Welcome back. In this video, we're going to be starting chapter 2, which is about solving linear equations and inequalities. As always, when we're starting a chapter, it's a good idea to look ahead, see what it is we're getting into, and then go from there. So this chapter, as I said, is on solving linear equations and inequalities. There are 7 sections in it. The first one, the titles of the sections look really similar. Solve equations first using subtraction and addition properties of equality, then solving using multiplication and division properties of equality. So the first 2 sections are really important. They're about the basics of how you solve equations. The 2-3, it says solve equations with variables and constants on both sides. So it's kind of more of the same, but more complicated equations. 2-4 says use a general strategy to solve linear equation. That kind of summarizes the first 3 sections. 2-5, solve equations with fractions or decimals. So that will be more equations, but of course, obviously having more fractions and more decimals in it. 2-6, solve a formula for a specific variable. We'll have to talk when we get closer to that about what a formula is like in comparison to just what you might think of as a regular equation. But we'll be using the same sorts of steps to get that done. And then finally in 2-7, solve linear inequalities. In that, as you'll find out, we'll be looking at less thans and greater thans and stuff like that, and not just equations with an equal sign in it. But luckily, a lot of the same steps will still apply. But of course, what we're doing and the results will be different. Okay, so let's get started with section 2.1 on solving equations using the subtraction and addition properties of equality. So before we do that, really, we should think again or remember again about what makes an equation an equation versus an expression, and that's the presence of an equal sign, right? When we write something like, let's just stick with numbers, 3 plus 5 equals 8, that's a true statement. It expresses the fact that 3 and 5, if you add them together, you do get 8, and that's true. The equation 3 plus 1 equals 10, that one's false, okay? An equation can be either true or false. Of course, we're interested especially in the true kind, but an equation has property that's either true or false. An expression may have a value, like 3 times 4 plus 1, that has a value of 13, but you can't say really that that's true. We're not saying that it's equal to something or less than something or greater than something, okay? An equation is a statement that 2 things are equal, and that statement may either be true or false, okay? And a solution is a replacement value for the variable that can make or will make the equation true. For example, x plus 2 equals 10. This equation, let's write that neater, x plus 2 equals 10. This equation is true if I replace the x by an 8, because 8 plus 2 is 10. On the other hand, if I replace the x with anything but 8, it will be false. That makes 8 a solution to this equation. Just to repeat, 8, if I replace the x by an 8, we get an equation that's true. If you replace the x by anything else, like 17, we get an equation that's false. The replacement value for the variable that gives a true statement is the solution. That's a noun, solution to an equation. Solving is the verb, or solve is the verb, that's the action of trying to find the solutions to an equation. So just to get us started, a couple of yes-no questions. We want to know first if y equals 4/3 is a solution of 9y plus 2 equals 6y plus 3. So how we can go about doing this is replace the y with 4/3 and decide if that makes a true equation or not. So 9 times 4/3 plus 2 equals 6 times 4/3 plus 3. Okay, so let me simplify both sides and then we'll see if it gives something that's true or not. Okay, 9 and 3, there's a common factor of 3 that can be divided out. It gives us 12 plus 2 on the left side. On the right side, a common factor of 3 can be divided out. This gives us 8 plus 3. Okay, and that says 14 is equal to 11, and that's false. So the answer to the question there is no. Okay, 4/3 is not a solution of the equation that's stated. Okay, let's try the next one next. we want to know if 7/5 is a solution of 5x plus 3 equals 10x minus 4. And our approach is going to be the same. We're going to replace the x by 7/5 and decide if that yields a true statement or not. So let's do the calculations. Okay, so 5 times x plus 3, 10 times x minus 4. Okay, so this will give us 7 plus 3 on the left, 14 minus 4 on the right. That's 10 equals 10, which is true. So the answer to this question is going to be yes. 7/5 is a solution to this equation. Okay, so of course, most of the time we're not just answering yes or no questions. We need to actually find the solutions. And so how do you go about finding the solutions is the subject really of this chapter. This section, we're focusing on using the addition and subtraction properties of equality. And so let's take a look at those. And I like these especially because they really are kind of common sense. They look like math. But really, if you think about them, they're going to make a lot of sense. Okay, so reading this off in symbols, A and B here are numbers. If A is equal to B, if two things are equal, if A is equal to B, then A plus C will equal B plus C. And additionally, A minus C will equal B minus C. So disregarding the symbols for just a second and thinking this through, we have two numbers A and B that are the same. If we add the same amount to two things that are the same, they're going to stay the same. If you subtract the same amount from the two, they're going to be the same. Okay, so let's think about that for a second. If you and your best friend are the same age, in 5 years, do you think you will still be the same age? Yes. If you take whatever your current age is, which is the same, and add 5 to it, it's going to stay the same. Okay, if you and your best friend have the same amount of money and you both go buy a can of soda out of the machine, then do you think you still have the same amount of money? If you started with the same amount of money and spent the same amount, you still have the same amount. Okay, the overall point here is that if you treat equals equally, they stay equal. Okay, so let's try to use this principle to help us solve a couple of little equations. So we're going to solve, first of all, this one, which says n minus 61 equals negative 57. So some number n has had 61 subtracted from it, and that has left us with negative 57. So what we're going to do is take that equation, and we're going to add 61 to both sides. Again, the thinking is that if you have two things that are equal, we can add the same amount to both sides, and that will preserve their equality. So n minus 61 plus 61 will just leave us with n on the left side, which was the plan. And then negative 57 plus 61 is going to be negative 4. So here our solution is going to be negative 4. Sometimes we like to write that in a curly brace, really pair of curly braces to really emphasize that that is a set of solutions. Okay. This next one, we have fractions in it, but that's okay. We have p minus 2/3 is equal to 5/6. We're going to add something to that. Both sides, we have to make sure we treat the two equals equally, right? We have to add the same amount on both sides. And so if you're concerned here, well, is it the 2/3? Is it the 5/6? Remember that our goal is to end up with the p all by itself and then whatever the answer is on the right side. Right now, the unknown has had 2/3 subtracted from it, so we must do the opposite operation and add 2/3. Of course, we will do that to both sides. Okay. All right, so this will leave us negative 2/3 plus 2/3 is 0, so the left side is just a p. And then we need 5/6 plus 2/3. So let's think on that for a minute. 5/6, 2/3 is how many sixths? That's 4/6, right? 2/3 and 4/6 are the same. 5/6 plus 4/6 makes 9/6. And 9/6 simplifies to 3/2. Okay, so 3/2 is our solution. Okay, remember, if you like, you can always replace the p with 3/2 in that equation and calculate to make sure that it is true. Okay. All right, this one has got some decimals in it, but we'll Just do the same basic thing. Here it says solve x minus 0.47 is equal to negative 2.1. So as before, we're going to want to get x by itself. So I'm going to rewrite it, leave space. So we have the unknown has had 0.47 subtracted from it. So we should add 0.47 to it. And then we have to add it to both sides, of course, to preserve the equality. Left side, we're subtracting and adding that 0.47, so that does nothing, which is what gives us the x alone on the left side. And then on the right side, we have negative 2.1 plus 0.47. So there we're adding together two numbers that differ in sign. So we're going to need to subtract their absolute values. Okay, so let's do that. That will take us a second. So that's a 0, 10, 3, 20 minus 14 is 16. So 16.3, but then the add end with the bigger absolute value is the negative one. So it's going to be negative, that should be 1.63. Okay. All right, so that does that. Okay, in this next one, we need to do a little bit of simplification first. So we'll begin by simplifying by combining like terms, and then we'll take any needed steps. So here I can see 8y minus 7y will be a single y. And then y minus 4 minus 7 is the same as y minus 11. Okay, so now we have y minus 11. We're going to want the y all alone, so we will add 11 to both sides. And that will give us y on the left side and 15 on the right side. So our solution here is just the 15. Okay, in the next one also, we're going to need to simplify. This time we're going to need to distribute to remove some parentheses. We're going to need to combine like terms, and then we will go from there. So for this one, take a minute, pause the video, and try it yourself, and then restart it and see how you did. All right, so let's begin by distributing that 5. We will have 5x and then minus 15. We'll have minus 4x, and then it's negative 10. As in the preceding example, we'll need to combine like terms. 5x minus 4x is a single x. Okay, x minus 15 is negative 10. We're going to need to add a 15 on both sides. Okay, that will leave us with x on the left side and 5 on the right side. Okay, so our solution this time is just 5. Okay, so we've seen in these examples that essentially we can add the same value to both sides of an equation or subtract the same value on both sides of an equation, and that preserves the equality. And our goal always is to isolate whatever the variable is to get the variable by itself. Okay, so more examples. This one has got a lot to it. There's a lot of parentheses that need to be removed, so we'll take care of that. We'll combine like terms. We'll just do this really carefully. So our first step is to distribute to remove some parentheses. So again, if you like, pause the video here and try it yourself and then see how you've done. So let me distribute. 4 times 2b is 8b. 4 times negative 3 will be negative 12. In the back, we have minus 7b. Okay, here's where my equal sign is gone. Then we have on the right side 6b minus 12, and then minus 6b plus 6. Okay, so you want to be really careful with that. Double negatives in there. Okay, simplifying each side separately. I'm not going to be like adding things to both sides at this point. I need to clean up both sides as much as I can first. 8b minus 7b is a single b. We'll have minus 12. And then on the right side, I can see there's a 6b and a minus 6b, so there's really no b's there. And then negative 12 plus 6 will be minus 6. We have b minus 12 is negative 6. And then we're going to add 12 to both sides. Okay, so then doing that, we'll be left with B is just 6. So our solution after all that is just 6. All right, so that's pretty exciting when you get one of those done. All right, so the next part has to do with translating from English into math. And so with equals, remember that an equality is a statement that two things are equal. That is, one thing is another thing. And so the words that can kind of signal that an equation is what you're looking at is forms of the verb to be. So phrases shown at the table to the right here, like is equal to, is the same as, results in, gives, was, will be, yields, things like that. Okay, so let's try. We're going to translate from English into math and then solve. Okay, so 10 more than a number gives 41. Okay, 10 more than, that's 10 plus. A number, I'm going to use n to stand for a number. Gives is where my equal sign will be. And then 41. I just chose n here because it's the first letter in the word number. If you used a different variable, that's okay. So 10 plus n equals 41. So we can use the commutative property to write that as n plus 10 equals 41. I just wanted to do that because it made me more comfortable to have a variable on the left side. Then I'm going to subtract 10 from both sides, right? And so this will give us n on the left side and 31 on the right side. So our number is 31, okay? Before we proceed, I did want to mention here where it says 10 more than a number, I translated that as an addition. The phrase 10 is more than a number. When the word is in there, that makes it a relational statement. And so that's where you would use the greater than sign. 10 is more than or is greater than a number. That's an inequality. I know it seems very picky, is the word is in there or is it not? But as you know, math is a pretty particular subject. 10 more than translates as 10 plus n. 10 is more than translates involving a greater than sign. Okay. The difference of 8m and 7m is negative 14. Difference means subtraction, right? So this will be 8m minus 7m. Is where our equal sign will be. That's the negative 14. Combining like terms, 8m minus 7m is a single m. And so our solution here is negative 14. Okay, so we've translated here from English into math. Okay, a couple of story problems next. Let's try these. Okay, for the first one, it says Emily and Caitlin are roommates. Together, they have 68 books. Emily has 26 books. We want to know how many books Caitlin has. So in working with story problems, it's almost always a good idea to let the variable be the thing that you're trying to find. In this case, it's how many books Caitlin has. I'm going to use the variable C for Caitlin, although if you use an X or an N, it doesn't really matter. This will be the number of books Caitlin has. Okay. All right. The part about Emily and Caitlin being roommates is not really helpful. We can ignore that. Together, they have 68 books. So that is the amount of books that Emily has and the amount of books that Caitlin has together make 68. We know that Emily has 26. So let me think. Caitlin plus Emily together should have 68 books. We're using C for Caitlin's books, and we know Emily has 26. Okay, and so that's going to give me my equation. C plus 26 is 68. Okay, and so that should make some sense. So let me subtract 26 from both sides so that will give us our C by itself. So then we'll have C on the left side, and then 68 minus 26 is 42. So Caitlin has 42 books. Okay, that'll do it. Okay, last one. Here it says Eddie paid $19,875 for his new car, which was $1,025 less than the sticker price. What was the sticker price? So I'm going to go with P for the sticker price, because that's what we're trying to find. And then the price that he paid, do you think he paid more or less than the sticker price? Okay. It says here that the 19,875, which was, that's equal sign, 1,025 less than the sticker price. So the 19,875 was 1,025 less than sticker price. Remember, with less than, you have to be careful about the ordering. And it's was because it was in the past tense. Okay, that's our is turned into a was because it's in past tense. All right, so then in order to get the P all by itself, we're going to take and add the 1,025 to both sides. Okay, so the P is on the right side this time, but that's okay. And then we need 19,875 plus 1,025. Okay, so that's 100. So it looks like 20,900. Okay, pretty sure. Let me check. That's 20,900. Okay, so the sticker price was 20,900. Okay, so that takes us to the end of this first part of section 2.1, and we've covered most of the really fun stuff. In the next part, we'll basically be doing some examples. In the meantime, let me know if you have any questions, and then have a great day.